So one of the motivating factors behind this challenge is tied to one of the Department of Defense's mandates, which is to participate in international humanitarian aid. And one of the inspirations for this is the recent rash of urban disasters, things like the tidal waves or most notably the nuclear meltdown at Fukushima in Japan in 2011.
The DARPA Robotics Challenge is an international competition that DARPA is putting on. There's over 100 teams that have registered for the virtual robotics challenge, which is done in software and simulation. 26 teams qualified, and now we're down to 8 teams that have been awarded prizes for completing the tasks. The goal of DARPA Robotics Challenge is to hopefully push robotics out of the laboratory into real-world environments so they can tackle challenging tasks such as Fukushima.
So these environments are designed for human beings to navigate and move around in, and they have doors and stairs and catwalks and narrow spaces and areas that aren't suited for robots that have big tank treads or wheels strapped to them. So by advancing this field of humanoid robotics, we can take these agile, dexterous machines and use them to get human beings out of harm's way. Now these environments are very complicated, and we don't really believe that full autonomy is the solution because computers just aren't there yet.
But I think one thing that sets us apart is our human interface group. We really look at how you design systems to work with people. And so you'll see our interface and the design of our algorithms is all set up from the beginning with the robot working in conjunction with the human throughout all tasks. And you'll see that in our setup.
So the DARPA Robotics Challenge was broken out into 3 tasks. One of them heavily based on walking, one of them based on driving, one of them based on using tools. And the way they did this is the walking challenge was sort of an obstacle course with mud and rubble and hills. The driving challenge was to have the robot actually drive an electric vehicle through an obstacle course with things like traffic cones and Jersey barriers. And then the tool simulation challenge was to use a fire hose, basically fit a hose to a pipe and turn a valve on.
So this is a good example of how the human and the robot work together as a team, as opposed to just teleoperating or relying on autonomy. We use a scripted behavior here to pick up the hose, but the autonomy, the script, fails, and you can see the hose did not get picked up properly. The operators are able to intervene and adjust the autonomy, adjust the scripting that enables us to re-grasp that hose and successfully complete the task.
Here you'll see a sticky situation we got ourselves in while trying to do the hose task. We ended up getting the hose caught on the leg of the robot, and this caused him to fall down, and he bounced under the table. But due to us deciding we wanted to spend a long time on reliability, we were able to build up a collection of strategies for handling situations like this. You'll see here where we can actually get the robot up to look around, see where it is, and then get on its hands and knees and crawl backwards out from under the table, and from there we can stand back up, sort of reset our limbs, and then continue where we were and complete the task.
So getting in the vehicle was by far the most complex task we had to tackle in the VRC. It was a very difficult challenge to do, and I think we tackled it pretty creatively. And what enabled us to successfully get in this vehicle was designing the system to allow the human to work in tandem with the robot as a team effectively. We had a lot of tools that enabled pose control and various ways to do pose control and manipulate the robot that provided us very accurate and reliable and repeatable performance in the very tight quarters that this vehicle provides.
One of the keystones to our approach for the DARPA Robotics Challenge and the virtual challenge specifically was to not try and hack anything together and to not leverage bugs and exploits in the simulation environment. We encountered a lot of them early on, and we chose to avoid exploiting them because we knew that those strategies wouldn't work on the real robot. So from the very beginning, we always kept that point of light in our eyes because we knew eventually we would have to adapt our strategies to a real machine running in the real physical competition, and we wanted to work towards that from the start and not have to shift gears halfway through. So this is one of the biggest teams we've ever had in our robotics group working on one project at one time, and it's been really, really awesome to see everyone come together. There was always a fantastic sense of teamwork and a fantastic sense of camaraderie, even when things were incredibly bleak during the competition, when things were really challenging. We never really lost our morale just because working with some of the talented, brightest young people in the field right now, we were always able to pull ourselves together and keep the goal in sight, and it's been a really, really eye-opening experience.